right now as you read this, something impossible is happening inside your body. 7 octillion atoms are existing in multiple states, at once defying everything logic tells you is possible. I'm curious, where are you in the world right now? And what time has brought you to this moment? Tonight we're stepping into the quantum realm, a hidden dimension that's been operating within you all along. And what we'll discover will fundamentally change how you see reality itself. If this mystery calls to you, stay a while. Perhaps leave a soft subscribe, or just listen. Let's begin January 2025. A discovery sent shockwaves rippling through the scientific community. The kind of tremor that makes physicists pause mid-equation and stare at their data in disbelief. At Brown University, researchers observed something that, according to everything we've understood about the quantum world for the past century, simply should not exist. They witnessed particles called fractional excitons behaving in ways that defy our most fundamental categories. Particles that refuse to be either this or that, but instead exist as both simultaneously in configurations we never imagined possible. These aren't just unusual particles exhibiting strange behavior. These fractional excitons are rewriting the rulebook of physics right before our eyes. For decades, we've organized the quantum world into neat categories, believing we understood the basic character of matter at its smallest scales. Nature, it seems, has been reading our textbooks and decided to add chapters we never dreamed of writing. This isn't theoretical speculation or mathematical abstraction. This is direct observation captured in laboratories, measured with precision instruments, confirmed and reconfirmed by multiple teams of scientists who can scarcely believe what they're seeing. But here's what will truly capture your imagination tonight. This discovery, as groundbreaking as it is, represents merely the beginning of our journey. Because what you're about to discover in the hours ahead will fundamentally transform how you understand reality itself, how you perceive the world around you, and most remarkably, how you see yourself within this cosmic story. You see, the quantum realm isn't some distant dimension, accessible only through billion-dollar particle accelerators, or existing only in the abstract mathematics of theoretical physics. It's not tucked away in some remote corner of the universe, waiting to be visited like an exotic destination. No, the quantum realm is here right now, closer to you than your next breath. It's living inside you at this very moment. While you process these words, while your eyes move across this screen, something impossible is happening within the boundaries of your body. 7 octillion atoms, each one a complete quantum system, are existing in multiple states, simultaneously. Every atom in your skin, in your bones, in the neurons firing thoughts through your brain, is performing quantum feats that would seem like pure magic if we judge them by the rules of our everyday experience. Every breath you draw pulls quantum particles into your lungs. Every heartbeat pumps blood, whose chemistry depends entirely on quantum interactions. Every thought crossing your mind emerges from quantum processes operating at scales almost too small to imagine. So why, you might wonder, do you experience only one solid, certain reality? If the quantum world is so fluid, so probabilistic, so full of particles existing in multiple states at once, why does the world around you seem so definite, so concrete, so reliably singular? Why don't you see the quantum strangeness directly. The secret to this profound mystery lies in what we're about to explore together. Tonight, you'll discover why light behaves as both wave and particle, and how this dual nature changes everything we thought we knew about the substance of reality. You'll learn how particles can genuinely exist in two places simultaneously, not as science fiction, but as experimentally verified fact. You'll understand why your observation, your conscious act of looking, actually participates in creating the reality you perceive. And no, this isn't metaphor or mysticism, and you'll encounter discoveries that will require you to reconsider everything you've ever assumed about the nature of existence itself. The quantum realm is calling, and it's been waiting for you all along. Researchers at MIT recently performed what they're calling the most elegant experiment in the history of physics. They stripped the famous double-slit experiment down to its quantum essentials, removing every distraction, every complication, leaving only the pure, irreducible strangeness at the heart of reality. And the result? It left every scientist in the room standing in stunned silence, because what they observed confirmed something so profoundly counterintuitive that even after a century of quantum mechanics, it still takes your breath away. Light refuses to follow the rules of logic as we understand them. In our everyday world, things must choose. They must commit to being one thing or another. Either you have waves, like ripples, spreading across the surface of a pond, carrying energy outward in all directions with no definite position, no solid boundaries, just continuous flowing motion. Or you have particles like marbles rolling across a table, occupying specific locations in space, following predictable trajectories, behaving like tiny solid objects with definite positions and momenta. These two categories seem fundamentally incompatible, as different as liquid and solid, as distinct as motion and stillness. But light looks at this binary choice and says with a kind of playful defiance, I refuse to choose. Light exists simultaneously as both wave and particle, holding these seemingly contradictory natures in perfect balance. It spreads out like a wave when it travels through space, interfering with itself, creating patterns that only waves can make. Yet when it interacts with matter, when it strikes your eye or triggers a detector, it arrives as discrete packets of energy, as individual photons behaving precisely like particles. And here's the truly mind-bending part, which nature light reveals depends entirely on how you choose to observe it. It's as if reality itself is playing an elaborate game of revelation and concealment, showing you one face while keeping its dual nature forever just beyond your complete grasp. Think of it like having a friend who appears completely transformed depending on where you encounter them. When you meet them at their office, they're impeccably professional, wearing a crisp suit, speaking in measured tones, focused and methodical, in every gesture embodying corporate precision. But when you visit them at home just hours later, they're wearing comfortable clothes, laughing freely, moving with spontaneous ease, seeming like an entirely different person altogether. You might genuinely wonder, are these the same individual? The answer is yes, but they're expressing different aspects of their nature, depending on the context of your interaction. This is precisely how quantum particles behave. They're not pretending or acting. They genuinely possess these dual natures, simultaneously revealing different aspects depending on how you choose to look. Right at this moment, every single photon of light touching your retina is performing this miraculous dance between wave and particle, between spread out possibility and localized actuality, between the fluid and the definite. But scientists at Stevens Institute of Technology have taken our understanding even further, developing mathematical frameworks that can actually quantify the waveness and particleness of quantum objects. They've created elegant curves mapping the relationship between these dual aspects, showing precisely how much wave character and how much particle character any quantum system exhibits in any given measurement. This isn't just fascinating physics for its own sake. Understanding and controlling wave-particle duality is opening entirely new technological possibilities. Quantum imaging systems that could see through solid objects, quantum communication networks that would be fundamentally impossible to eavesdrop upon, and quantum sensors capable of detecting diseases before any symptoms manifest, reading the subtle quantum signatures of cellular malfunction. Yet perhaps the most astonishing demonstration of wave-particle duality comes from an experiment that sounds like pure fantasy. Scientists managed to separate the wave and particle attributes of a single photon, demonstrating what's called the quantum Cheshire cat effect, named after Lewis Carroll's famous character, who could separate his grin from his body. In this experiment, they showed that in the quantum realm, the properties of particles can actually exist separately from the particles themselves. Imagine if you could separate your reflection from your physical body, letting your reflection walk around independently while your body remained in place, or detaching your shadow and sending it off on errands while you stayed home. This is the level of strangeness we're dealing with in the quantum realm, where our most basic assumptions about how properties relate to objects simply dissolve into quantum possibility. Lighted seems read the book on how not to follow rules and decided it could do even better, writing its own chapter on being magnificently, impossibly both. But this dual nature of light is just the beginning of quantum strangeness. If I told you that you could be in two places at the same time, you'd probably laugh, dismissing it as impossible fantasy, as something that violates every intuition you've built up through a lifetime of experiencing yourself as singular, localized, definitely here and not there. And you'd be right to be skeptical about yourself. But here's what will shake that certainty. The particles that make up your body are doing exactly this right now, at this very moment, existing in multiple places simultaneously, and they've been doing it since the moment you were born. This is superposition, perhaps the most reality-bending principle in all of quantum mechanics. Superposition doesn't mean a particle could be here or there, waiting for us to discover which location it secretly occupied all along. No, superposition means the particle genuinely, physically exists in multiple states, in multiple locations, doing multiple things all at once until the moment someone observes it. A classical computer bit must be either 0 or 1 off or on, committed to a single definite state. But a quantum bit, a qubit, can be 0 and 1 and every possible combination in between, all simultaneously, all equally real, holding multiple realities, in perfect quantum balance, until observation causes one possibility to crystallize into actuality. Nature has known this secret for 3 billion years. Long before humans developed quantum theory, long before we even existed, as a species, plants were already exploiting superposition to achieve something we're only now beginning to appreciate. When sunlight strikes a leaf, the energy captured by chlorophyll molecules doesn't travel along a single path to reach the reaction centers where photosynthesis occurs. Instead, that energy explores all possible pathways simultaneously through quantum superposition testing, every route at once, finding the most efficient path through this quantum parallel processing. This is why photosynthesis achieves near perfect efficiency, why plants can extract almost every bit of usable energy from sunlight. They're not using trial and error. They're using quantum mechanics, running countless experiments simultaneously in superposition, then collapsing into the optimal path. Trees have been operating quantum computers for billions of years, while we're only just now learning to press the power button. But quantum superposition isn't limited to the microscopic realm of individual photons and electrons. Scientists have achieved something that challenges our most fundamental intuitions about where the quantum world ends and the classical world begins. They constructed what they call a piezoelectric tuning fork, comprising approximately 10 trillion atoms, and they managed to place this macroscopic object into a superposition of vibrating and not vibrating simultaneously. Read that number again: 10 trillion atoms, all existing in multiple states at once, all participating in a single quantum superposition. This isn't an individual particle performing quantum tricks. This is an object you could almost see with the naked eye, an object composed of more atoms than there are humans on Earth. And it's existing in superposition, genuinely doing two contradictory things at the same moment in time. Every enzyme in your body, every molecular machine that enables your metabolism, your digestion, your ability to extract energy from food and convert it into life, is exploiting quantum superposition right now to make you possible. Think of it this way: before you open your refrigerator, that last piece of cake exists in superposition. It's both there and gone, eaten and uneaten, present and absent, all at once in a strange quantum limbo of culinary possibility. Only when you open the door and look inside, when you observe and measure, does reality decide which possibility becomes actual. Of course, in practice, macroscopic objects like cake don't maintain quantum superposition because they're constantly being observed by their environment, by air molecules, by light, by thermal radiation. But at the quantum scale, this is precisely how reality operates. This brings us to Schrödinger's famous thought experiment with the cat in the box. Most people encounter this as a philosophical puzzle, as a kind of joke about the absurdity of quantum mechanics. But here's what's crucial to understand: Schrödinger wasn't making a joke. He was providing an exact description of how quantum mechanics actually works. According to the mathematics of quantum theory, taken seriously and followed to their logical conclusion, the cat in the sealed box genuinely exists in a superposition of alive and dead states until someone opens the box and observes it. At the quantum level, before observation, the cat is truly both alive and dead, simultaneously existing in this impossible superposition until consciousness enters the picture and collapses the quantum wave function into one definite reality or the other. Schrödinger probably regrets using a cat as his example, though. Now everyone keeps asking, but what about dogs? What about hamsters? What about that annoying parrot my neighbor owns? The quantum realm refuses to be pinned down, refuses to commit to single answers, holding infinite possibilities in its patient, mysterious hands until the moment we look. Yet superposition, remarkable as it is, pales beside what comes next. Albert Einstein, arguably the greatest scientific mind of the 20th century, the man who reimagined space and time, who revealed that mass and energy are two sides of the same coin, who showed us that gravity curves the very fabric of space-time itself, encountered something in quantum mechanics that he simply could not accept. He called it spooky action at a distance, and that word choice is telling. Einstein, who revolutionized our understanding of reality, who fearlessly challenged centuries of physics, found quantum entanglement so disturbing, so contrary to his deepest intuitions about how the universe should work, that he rejected it outright. He insisted it couldn't be real, that there must be some hidden mechanism we hadn't yet discovered, some missing piece that would restore sanity to the quantum world. Einstein was wrong. Beautifully, profoundly, completely wrong. Quantum entanglement creates connections that transcend space and time in ways that seem impossible by any classical understanding. When two particles become entangled, they form a bond so intimate, so fundamental, that they cease to be truly separate entities. They become a single quantum system, even when separated by vast distances. Measure one entangled particle, affect its quantum state in any way, and its entangled partner responds instantaneously, regardless of the distance between them. Not quickly, not at the speed of light, instantaneously. The correlation between entangled particles appears to be immediate happening, faster than any signal could possibly travel between them, as if the particles remain connected by invisible threads woven from the fabric of quantum reality itself. Recent experiments have pushed entanglement to extraordinary distances, confirming its reality beyond any shadow of doubt. Using satellites, researchers have demonstrated quantum entanglement over distances exceeding 200 kilometers, with photons separated by the vast space between Earth and orbit, maintaining their quantum correlation perfectly. Einstein's skepticism, rooted in his conviction that nothing could influence anything else faster than light speed, has been definitively disproven. The universe is far more interconnected, far more mysteriously unified than classical physics ever suggested. But entanglement isn't just happening between separated particles floating through space in carefully controlled laboratory experiments. Inside every single proton in your body right now, at this very instant, quarks and gluons are maximally entangled with each other across distances smaller than 1/4,000,000th of a meter. These subatomic particles, the fundamental constituents of matter, are so deeply entangled that they cannot be described as separate entities at all. They exist as a unified quantum whole, their properties so correlated, so interconnected, that affecting one immediately affects all the others. This entanglement is what holds protons together, what prevents them from flying apart, what gives matter its solidity and structure. Entanglement isn't just a curiosity, it's literally holding the fabric of your physical existence together, maintaining the coherence of matter itself. At this moment, in every single cell of your body, quantum entanglement is occurring 100 trillion times per second, maintaining the quantum correlations that make your continued existence possible. The practical applications of entanglement are beginning to emerge from laboratories into the real world, with implications that will transform human civilization. China has already launched the Messiah satellite, demonstrating that entangled photon pairs can serve as the foundation for communication systems secured by the fundamental laws of physics themselves. Here's how it works. When information is encoded in entangled quantum states and transmitted between parties, any attempt to intercept or eavesdrop on that communication inevitably disturbs the entanglement in detectable ways. The quantum correlation is so delicate that merely observing it changes it, and both sender and receiver are immediately alerted to any security breach. This isn't encryption that might be broken by sufficiently powerful computers or clever algorithms. This is security guaranteed by quantum mechanics itself. By the basic structure of reality, we're approaching a future where our most sensitive communications, from personal messages to financial transactions to state secrets, will be protected not by human ingenuity, but by the immutable laws of the quantum realm, where security exists at the cosmic level, and entanglement, mysterious as it seems, emerges from something even more fundamental. What happens when the universe itself is fundamentally uncertain? When reality refuses to commit to definite answers until forced to by observation? Your first instinct might be to imagine chaos, to picture a universe so unstable and unpredictable that nothing coherent could possibly exist within it. But here's the paradox that will shift your entire perspective. This uncertainty, this fundamental indefiniteness at the heart of quantum reality is precisely the reason you exist at all. The uncertainty principle reveals something profound and strange about the nature of reality itself. The more precisely you know a particle's position, the less precisely you can know its momentum, its velocity, its motion through space. Conversely, the more accurately you measure a particle's momentum, the fuzzier its position becomes, spreading out into a cloud of probability. And here's what's crucial to understand. This isn't a limitation of our measuring instruments, not a technical problem waiting for better technology to solve. This is a fundamental feature of reality itself, built into the deepest structure of existence. At the quantum scale, there is an irreducible fuzziness, a basic indefiniteness, a core uncertainty that cannot be eliminated no matter how clever our experiments become. Particles don't have precise positions and precise momenta simultaneously. It's not that we don't know these values. It's that these values don't exist in the way we imagine they should, with classical definiteness. Reality at its foundation is genuinely, irreducibly fuzzy. Now here's the twist that transforms uncertainty from problem to miracle. Without this quantum uncertainty, existence, as we know it, would be impossible. If particles could have perfectly defined positions and momenta simultaneously, if the universe operated with classical precision, all the way down, atoms would collapse in on themselves in a tiny fraction of a second. Electrons would spiral into atomic nuclei. Matter would implode, and the entire universe would reduce to an undifferentiated soup of collapsed matter. Stars wouldn't shine because the quantum uncertainty that allows nuclear fusion wouldn't exist. Chemical bonds couldn't form because the electron clouds that create molecular structures depend entirely on quantum indefiniteness, the rich complexity of chemistry that makes life possible, that creates the bewildering diversity of molecules and materials in living systems, would simply vanish if reality were perfectly certain. Uncertainty isn't a bug in the cosmic operating system. It's the feature that makes everything possible, the creative principle that allows existence to flourish. The uncertainty principle creates space, both literally and metaphorically, for the dance of existence to unfold. It prevents the universe from collapsing into frozen definiteness, maintaining a generative openness, a field of quantum possibility from which all structure and complexity emerge. Think of uncertainty as breathing room built into the fabric of space-time itself, allowing reality the flexibility to explore possibilities, to create novelty, to generate the endless forms and patterns we observe throughout nature. Right at this moment, quantum uncertainty is the reason you can breathe, think, and exist. Every oxygen molecule entering your lungs, every glucose molecule powering your cells, every neurotransmitter crossing synapses in your brain depends absolutely on quantum uncertainty, maintaining the chemical processes of life. These four pillars don't stand in isolation, separate principles occupying different corners of quantum theory. They interweave, they harmonize, they create together what we might call the quantum symphony, a magnificent orchestration of strangeness that underlies and enables everything you've ever seen, touched, tasted, or experienced. Wave-particle duality allows matter and energy to explore multiple forms simultaneously. Superposition enables systems to try all possibilities at once. Entanglement connects separated parts into unified wholes, and uncertainty provides the creative space for it all to happen. Together, they compose the music of reality itself, the fundamental score that the universe performs in every moment of its existence, creating the world you experience from quantum possibility. And as these four pillars settle into your understanding, something beautiful is beginning to emerge from them. What if I told you that computers will soon never need charging? That your phone could operate forever without a power cord? That materials could heal themselves when damaged, repairing cracks and breaks? As automatically as your skin closes a wound, you'd probably smile and say, "That's science fiction, interesting fantasy, but impossibly far in the future." And I would lean forward and whisper back, "It's happening right now, in laboratories around the world, emerging from the quantum realm into tangible reality." At the University of California, Irvine scientists have created something that shouldn't exist, according to everything we thought we knew about the phases of matter. They took a material called hafnium pentatelluride and subjected it to extraordinarily intense magnetic fields, pushing the material into conditions far beyond anything it would experience in nature. And then, something astonishing happened. The material's behavior changed completely, transforming into an entirely new phase of quantum matter that operates by rules we're only beginning to understand, exhibiting properties that seem to defy the fundamental constraints of physics and chemistry as we've known them. Here's what happened at the atomic level, in a dance of particles, so precisely choreographed, it takes your breath away. Electrons, which carry negative charge, and their oppositely charged counterparts, called holes, which represent missing electrons in the material's structure, spontaneously paired up to form entirely new particles called excitons. These aren't just electrons and holes sitting next to each other. They're bound together by quantum forces into unified quantum objects that behave unlike anything in our previous catalog of matter. The result is what physicists call a quantum liquid, phase of matter so strange that it refuses to follow even the basic rules that govern conventional liquids, solids, and gases. These quantum liquids exhibit properties that sound like they've been pulled directly from fantasy novels, but are absolutely verifiably real. Imagine materials from which you could construct computers that charge themselves eternally, drawing energy from quantum vacuum fluctuations, never requiring connection to external power sources operating indefinitely on the subtle energy that permeates supposedly empty space. Imagine electronics that don't just survive in the harsh conditions of deep space, but actually become more efficient and reliable in extreme environments. Temperature near absolute zero, no problem. Intense cosmic radiation that would destroy conventional electronics. These quantum materials shrug it off their quantum coherence, protected by properties we're only beginning to exploit. Think about what this means for the children of the next generation. They'll grow up in a world where the phrase low battery has become as quaint and obsolete as rotary phones and typewriters, a relic of a more primitive technological era. The applications emerging from these discoveries promise to transform human civilization in ways both subtle and profound. Consider self-healing materials that don't just resist damage, but actively repair themselves through quantum processes. When a crack begins to form in such a material, quantum sensors built into its structure detect the disruption, instantly sensing the break in quantum coherence across the material's lattice. The material then responds by rearranging its atoms, guided by quantum tunneling effects that allow atoms to move through energy barriers that would be insurmountable in classical physics, until the crack simply vanishes, sealed as perfectly as if it had never existed. It's like human skin, closing a wound, but happening in metal, in ceramic, in materials we use to build everything from spacecraft to surgical instruments. Or consider computers that draw their operating power not from batteries or wall outlets, but from the quantum vacuum itself, from the endless fluctuation of virtual particles that fill even the emptiest space. These machines would operate perpetually limited only by the structural integrity of their components, not by energy supply. Data centers consuming vast amounts of electricity could shrink to a fraction of their current power requirements. Personal devices could run indefinitely. The entire infrastructure of modern computing could transform into something far more sustainable and far less dependent on conventional energy sources. And perhaps most exciting for space exploration electronics that thrive in conditions that would annihilate current technology. Exploring Mars becomes trivially easy when your instruments grow more reliable in the harsh Martian environment. Sending probes to the outer solar system, or even beyond to neighboring star systems, becomes feasible when you know your electronics will function flawlessly for decades or centuries, regardless of radiation exposure or extreme temperatures. These quantum materials don't just tolerate harsh conditions, they seem almost designed for them. Finally, technology that works in terrible conditions, as reliably as the old Nokia phones we all remember fondly, except now it's doing so through quantum physics rather than brute force engineering. Now, let's venture even deeper into quantum strangeness with what scientists call quantum liquid crystals, materials that exist in a state so peculiar that our ordinary vocabulary struggles to describe them. You know that water can exist as ice, liquid, or vapor, 3 distinct phases with completely different properties. Quantum liquid crystals exist at the boundaries between different exotic quantum phases, occupying a kind of twilight zone where they're neither fully one state nor another, but something paradoxically in between. They exist at the edge at the threshold, belonging nowhere, and yet possessing unique properties precisely because of their boundary existence. These materials show sharp, dramatic drops in electrical conductivity at specific critical points, as if a switch has been flipped at the quantum level. They exhibit remarkable resistance to radiation damage, almost as if protected by invisible quantum shields that deflect or absorb ionizing particles before they can disrupt the material's structure. Their applications span from next-generation smartphones with displays that never degrade to spacecraft hulls that protect astronauts from cosmic radiation, from quantum sensors of unprecedented sensitivity to computing substrates that remain stable under conditions that would vaporize conventional materials. Think of quantum liquid crystals like a person standing precisely in a doorway, neither inside nor outside, existing in that liminal space between 2 rooms. Classical physics says you must be in one room or the other, but quantum liquid crystals refuse this binary, maintaining their existence in the boundary itself, and discovering that this impossible position grants them powers unavailable to materials fully committed to either phase. But perhaps the most reality-shaking discovery of all involves information itself undergoing phase transitions, behaving like matter that can freeze and melt and evaporate. Information we've always assumed is just information, abstract, unchanging in its fundamental nature, simply data that can be stored and transmitted. But quantum information, it turns out, is far stranger. Quantum information can undergo phase transitions just as dramatic and fundamental as water freezing into ice or boiling into steam, depending on the delicate balance between quantum entanglement and measurement, between coherence and decoherence. Quantum information can exist in profoundly different phases, each with its own characteristics and capabilities. Scientists have identified critical points where the nature of quantum information itself transforms boundaries in parameter space, where quantum systems suddenly shift from one informational phase to another. Cross these thresholds, and quantum computers change their fundamental character. Quantum communication networks alter their capabilities. Quantum sensors transform their sensitivity. This opens entirely new ways of thinking about computation communication and the fundamental nature of reality itself, suggesting that information might be more basic than matter or energy, that the universe, at its deepest level, might be a vast quantum computer, processing the information that creates everything we experience as physical reality. Your thoughts, right now, the ideas forming in your mind as you process these words, might not be just electrochemical signals confined to your brain. They might be patterns of quantum information interacting with the informational substrate of the universe itself, ripples in the quantum field that underlies all existence. Now, with these mysteries unfolding before us, a deeper question emerges naturally from everything we've discovered. You've now seen the 4 pillars that support quantum, reality, wave particle, duality, superposition, entanglement, and uncertainty. You've witnessed the miraculous new states of quantum matter being coaxed into existence in laboratories around our planet. But the biggest question remains unanswered, hanging in the air between us. What does all of this actually mean for you? How does quantum mechanics with its impossible particles and strange new materials connect to your lived experience, to the person you are, to this moment of consciousness? Reading these words, here's the truth that will fundamentally reframe your understanding. Quantum mechanics is not some abstract theory describing distant realms you'll never visit or exotic particles you'll never encounter. Every single atom in your body is a complete quantum system operating according to these same principles we've been exploring. Every chemical bond holding your molecules together is a quantum interaction electron, clouds overlapping and sharing quantum states to create the structures that make you possible. Every biological process enabling your life depends absolutely on quantum effects from the quantum tunneling that allows enzymes to catalyze reactions, to the quantum coherence that enables photosynthesis in the plants, producing the oxygen you breathe, to the quantum computations possibly happening in the microtubules of your neurons as you think and feel and experience consciousness. The quantum realm isn't somewhere else. You are living inside it, composed entirely of. It's sustained moment by moment by its strange and beautiful principles. Consider the fusion reactions in the sun's core that create the light illuminating your world right now. Those reactions depend on quantum tunneling, allowing hydrogen nuclei to overcome electromagnetic repulsion and merge into helium. The photons from those fusion reactions travel 93 million miles through space, arriving at Earth as particles when they strike your retina, but spreading through space as waves. Those photons trigger quantum changes in rhodopsin molecules in your eyes, initiating cascades of quantum biochemistry that eventually become neural signals, electrical impulses racing through quantum mechanical ion channels in your neurons, creating thoughts, perceptions, the experience of seeing. From the sun's core to your consciousness, it's quantum mechanics, all the way down and all the way up, an unbroken chain of quantum processes, creating every aspect of your experienced reality. You're not learning about quantum mechanics as some external subject. You're learning about yourself about the quantum nature of your own existence. The quantum realm challenges us to expand our concepts of what's possible, to embrace uncertainty, not as an obstacle, but as a creative principle that makes existence richer and more open to novelty. It invites us to recognize that the universe is far more mysterious, far more interconnected, far more beautiful than our everyday classical intuitions suggest. We live in a reality that maintains multiple possibilities in superposition until observation selects actuality, where distant particles remain correlated through entanglement that transcends space, where uncertainty creates the breathing room necessary for matter and life and consciousness to exist at all. The universe is not a cold mechanical clockwork grinding through predetermined motions. It's a quantum symphony, a magnificent orchestration where every particle plays its part in creating harmonies that manifest as galaxies, stars, planets, organisms, minds. Every quantum interaction is like a note in this cosmic composition, and together they create the music of existence itself, the ongoing improvisation that is reality, continuously creating itself moment by quantum moment from fields of possibility into the world you experience. The quantum realm has shown us that we inhabit a universe stranger and more wondrous than we ever imagined, and we've only begun to explore its depths. Tonight, you've discovered light's dual nature particles in superposition, instantaneous entanglement, and uncertainty as life's foundation. You've seen new quantum materials emerging that will transform civilization, but everything so far happens at microscopic scales. What occurs when quantum effects reach objects you can see? And more personally, does your consciousness participate in creating reality, or is that just poetry? In our next journey, you'll discover experiments showing consciousness influences quantum systems. You'll learn your brain might operate as a quantum computer. You'll find evidence that present choices can alter the past. This journey has just begun, and you are its center. What you've learned isn't distant theory, it's the instruction manual for your reality. The deepest mystery awaits: how consciousness and quantum mechanics create existence itself. Let your breathing slow. These mysteries remain when you wake, but the most profound part still waits: discovering your role in this quantum universe. Sleep well, or continue onward. Both are perfect quantum choices. Welcome back to this gentle exploration where science meets wonder. If you're continuing from where we left off, or if you're just now finding your way here, you're exactly where you need to be. Let's venture deeper together into mysteries that grow more personal, more immediate with every discovery. We've explored how individual particles perform quantum feats at scales almost too small to imagine electrons in superposition, photons behaving as waves, and particles atoms entangled across distances. But quantum mechanics has refused to stay confined to the microscopic realm where physicists first discovered it. Something extraordinary is happening in laboratories around the world. Quantum effects are scaling up, emerging from the invisible into the visible, manifesting in objects large enough that they challenge our intuitive boundary between the quantum world and the classical world we experience every day. Scientists have successfully created quantum entanglement between objects you could almost see with your naked eye, objects so large they contain not millions or billions, but trillions of atoms, all participating together in a single quantum state. Imagine two tiny beams of silicon, each about 10 micrometers long, roughly the width of a human hair. These beams can oscillate like microscopic guitar strings, vibrating back and forth in response to energy. Researchers have managed to entangle these beams so completely, so profoundly, that when one beam vibrates, its partner instantly responds in perfect correlation, even though they're physically separate, even though no signal passes between them, as if they're connected by invisible quantum threads woven through the fabric of reality itself. Think about that for a moment. We are not talking about individual electrons anymore, not discussing abstract particles existing only in mathematical descriptions. We are talking about objects containing billions upon billions of atoms, macroscopic structures that approach the threshold of visibility, all somehow participating in a single unified quantum state. It's as if two orchestras on opposite sides of the world could play in perfect harmony without any communication between them, without any conductor coordinating their movements, their instruments synchronized by mysterious quantum correlations that transcend space and time. Another team of researchers pushed even further into the macroscopic realm, creating entangled aluminum drumheads, each about the width of a human hair, manufactured onto silicon chips through exquisitely precise fabrication techniques. Using carefully controlled microwave pulses, they nudged these drums into correlated motion. Whereas one drum head moved up, the other moved down in exact opposite phase, maintaining this quantum correlation across thousands of oscillations. These aren't individual particles anymore. These are objects you could photograph under a microscope, structures containing trillions of atoms, all dancing to the rhythm of quantum mechanics, as if the entire assembly were a single quantum entity. There's something almost magical about witnessing the invisible realm of quantum mechanics emerging into visibility, like watching a ghost materialize from mist into solid form, like seeing the hidden foundations of reality reveal themselves in the world you can touch. This scaling of quantum effects opens possibilities that read like wishes from science fiction, but are rapidly becoming engineering reality. Quantum sensors of unprecedented sensitivity could detect gravitational waves rippling through space-time, from black holes colliding billions of light years away, measuring distortions in space smaller than the width of a proton. These sensors exploit quantum entanglement and superposition to achieve precision that classical physics declares impossible, reaching sensitivity limits set not by human engineering, but by the uncertainty principle itself, by the fundamental granularity of reality. Imagine sensors so delicate they could detect a single photon bouncing off a distant spacecraft millions of kilometers away, or measure magnetic fields with such precision they could map neural activity in the human brain without any physical contact, reading the subtle magnetic signatures of thoughts themselves. Quantum communication networks are emerging from laboratories into limited deployment, creating communication systems that are fundamentally, provably unhackable by the laws of physics themselves. Information travels not through cables carrying electrical signals or radio waves carrying electromagnetic oscillations, but through the instantaneous correlations of entangled particles, creating links where Any attempt at eavesdropping inevitably disturbs the quantum state and alerts both sender and receiver to the intrusion. China's Mikius satellite has already demonstrated quantum key distribution over distances exceeding 1,000 kilometers, proving that quantum communication can work not just on laboratory benches, but across continental and eventually global scales. We're approaching a future where privacy isn't protected by clever mathematics that might someday be broken, but by the immutable structure of quantum reality itself. But perhaps the most mind-bending achievement in quantum scaling involves extracting energy from what we call empty space, from the quantum vacuum that fills the universe. You see, what we call empty space, the void between particles, the nothing that seems to exist between everything, isn't really empty at all. It seethes with quantum activity, filled with virtual particles that constantly pop into existence in particle-antiparticle pairs and disappear in time frames so brief they exist more as quantum possibilities than classical actualities. Yet these quantum vacuum fluctuations are real enough, tangible enough to produce measurable effects, like the Casimir force that pushes parallel metal plates together in vacuum, and researchers have discovered they can be harnessed for practical purposes. Scientists have developed techniques to extract energy from these vacuum fluctuations to teleport energy across microscopic distances by manipulating quantum field fluctuations, essentially surfing on waves of quantum nothingness, drawing usable energy from the fundamental structure of space-time itself. While the amounts of energy involved remain tiny, measured in fractions of electron volts, barely enough to nudge individual atoms, the principle opens entirely new ways of thinking about power generation and energy storage. It's a bit like learning to sail using winds that blow through empty space, harnessing forces that classical physics says shouldn't exist, but quantum mechanics reveals as fundamental features of reality. We're literally learning to surf on the quantum foam of existence itself, riding waves of possibility that emerge from and dissolve back into the vacuum, extracting something from nothing through the strange alchemy of quantum mechanics. The boundary between quantum and classical, once thought to be sharp and definite, a clear line separating the weird microscopic realm from the sensible macroscopic world, is revealing itself as blurry and negotiable. We are discovering that quantum effects can persist in larger and larger systems, that the strange principles governing atoms and photons can, under the right conditions of isolation and control, govern objects we can see and touch. This suggests something profound. Perhaps there is no fundamental boundary, no sharp transition where quantum mechanics stops and classical physics begins. Perhaps the universe is quantum all the way up quantum at every scale, and what we call classical behavior is just quantum mechanics averaged over enormous numbers of particles. Quantum strangeness hiding in plain sight beneath the appearance of classical certainty, waiting to be revealed when we learn to look properly. The quantum realm isn't somewhere else, isn't confined to the invisibly small. It's here in objects approaching human scales, ready to transform technology and deepen our understanding of reality's foundations. As quantum effects scale up from microscopic to macroscopic, as the boundary between quantum and classical, reveals itself as permeable and ambiguous, a profound question emerges that strikes at the very heart of reality and touches something deeply personal. What exactly causes quantum superposition to collapse into definite states? We've said repeatedly throughout this journey that observation, that measurement, causes the quantum wave function to collapse, forcing particles to choose definite positions, definite values, definite realities from the haze of quantum possibility. But what constitutes an observation? Does it require a conscious observer, a mind capable of awareness and intention? Or can any physical interaction with the environment cause collapse? Is consciousness somehow special in quantum mechanics, playing a unique role that inanimate matter cannot? Or is this just poetic language describing mundane physics? These questions aren't merely philosophical speculation, any more abstract debates confined to late-night conversations among students and professors. They're being tested, probed, examined through carefully designed experiments that are yielding results so intriguing, so suggestive, so difficult to explain through conventional frameworks that they're forcing scientists to reconsider assumptions about the relationship between mind and matter that have stood essentially unchallenged for centuries. At Princeton University, researchers have been conducting experiments for decades that seem to show something extraordinary, something that challenges our materialist assumptions. Human consciousness can measurably influence quantum systems. They created devices called random event generators that produce truly random sequences of numbers based on quantum decay processes, on the fundamental randomness built into quantum mechanics itself at the most basic level. These devices should be completely unpredictable, their output determined by nothing but the intrinsic uncertainty of quantum mechanics, influenced by no external factors, no hidden variables, no deterministic mechanisms, representing pure quantum randomness, distilled into numerical form. Yet when human subjects focus their conscious intention on these devices, attempting through sheer mental effort to influence the random output, attempting to bias the results in one direction or another, through focused attention and willpower, something remarkable happens that shouldn't happen if consciousness is merely a byproduct of brain chemistry with no special physical significance. The devices begin producing sequences that deviate ever so slightly from pure randomness in the direction of the subject's intention. The effect is small, barely detectable, above the noise of statistical fluctuation, requiring thousands or tens of thousands of trials to demonstrate conclusively through rigorous statistical analysis. But it's been replicated in laboratories around the world with remarkable consistency, surviving peer review and skeptical scrutiny, suggesting that something genuine is occurring, that consciousness might indeed have some subtle but real influence on quantum systems. Imagine if your consciousness, your awareness, your very thoughts and intentions could reach across the seemingly impermeable boundary between mind and matter to influence the quantum processes that underlie physical reality, not through any known force or field, not through electromagnetic radiation or gravitational effects, but through some connection we don't yet understand, some bridge between the subjective and objective that quantum mechanics is just beginning to reveal. This leads us into quantum consciousness theories, where some of the most brilliant and controversial minds in contemporary science are exploring the possibility that awareness itself, that subjective experience, that the feeling of being you, emerges from quantum processes operating in the brain. According to these theories, particularly the orchestrated objective reduction model proposed by mathematical physicist Roger Penrose and anesthesiologist Stuart Hameroff, consciousness arises from quantum computations occurring in microtubules within neurons. Microtubules are tiny protein structures, hollow cylinders assembled from tubulin proteins that help maintain cellular architecture, giving cells their shape and enabling intracellular transport of materials. But Penrose and Hameroff propose they serve another more mysterious function, acting as quantum computers, processing information through superposition and entanglement at room temperature in the warm, wet, noisy environment of the living brain, where quantum effects should theoretically disappear almost instantly. The theory suggests that consciousness emerges when quantum information in these microtubules reaches a critical threshold of complexity and integration, causing what they call orchestrated objective reduction, a process where quantum possibilities collapse into conscious experiences through a mechanism connected to the fundamental structure of space-time itself to quantum gravity effects operating at the Planck scale. It's as if your brain is constantly performing quantum computations, holding multiple possibilities in superposition, exploring different potential thoughts and perceptions simultaneously until the quantum state becomes unstable enough to collapse. And that moment of collapse, that transition from quantum possibility to classical actuality, is precisely what you experience as a conscious thought, a decision, a moment of awareness, crystallizing from quantum indeterminacy into definite subjective experience. This theory helps explain some of the deepest mysteries of consciousness that have puzzled philosophers and neuroscientists for centuries, mysteries that seem intractable from purely classical perspectives. How does your brain bind together information from different senses, processed in different brain regions, separated by centimeters of neural tissue, into unified perceptions that feel seamless and immediate? When you bite into an apple, your brain somehow combines the visual appearance of its red skin processed in your occipital lobe, the sound of the crunch as your teeth break through, processed in your temporal lobe, the sweet tart taste on your tongue, processed in your insular cortex, the fresh scent reaching your nose, processed in your olfactory bulb, and the tactile sensation of firm flesh and smooth skin, processed in your parietal lobe, into one seamless, integrated, unified experience of eating an apple. Classical neuroscience struggles to explain how this binding occurs, how separate neural processes processing different sensory modalities through different pathways get coordinated into unified conscious experience without any apparent binding mechanism, without any central processor integrating the disparate streams. Quantum consciousness theory suggests that entanglement between quantum processes in different brain regions could create the instantaneous correlations necessary for unified experience, that your visual cortex processing color, your auditory cortex processing sound, your gustatory cortex processing taste, your olfactory cortex processing smell, and your somatosensory cortex processing touch might all be quantum mechanically entangled, allowing them to function as a unified quantum system rather than separate classical computers trying to coordinate through slower chemical and electrical signals that would introduce perceptible delays. Your experience of biting that apple, that single unified moment of integrated sensation, might be a single quantum event, a unified collapse of quantum superposition across multiple brain regions happening simultaneously, creating the seamless integration of sensation you call consciousness, the feeling that all these different sensory streams are happening to one unified you. Now we venture into territory that will challenge your most fundamental assumptions about cause and effect, about the arrow of time that seems to flow in only one direction, from past through present into future. In our everyday experience, causality is straightforward and unidirectional. Actions in the present create effects in the future. You drop a glass and it shatters. You plant a seed, and weeks later, a plant grows. The past influences the future, never the reverse. This seems so obvious, so self-evident, that questioning it feels absurd. But in the quantum realm, time doesn't flow in the steady, predictable, one-directional way we experience in our macroscopic lives. Quantum particles can influence their own past states through a phenomenon called retrocausality, where the future appears to reach back and affect the past in ways that seem to violate everything we think we understand about temporal ordering and causal structure. Experiments have demonstrated something that sounds impossible. Decisions made about how to measure a particle can affect the particle's behavior retroactively, as if the particle somehow knew ahead of time how it would be observed and adjusted its past behavior accordingly to remain consistent with that future measurement. These are called delayed choice experiments, and they push our understanding of causality to its breaking point. Here's how they work. Imagine sending a photon through an apparatus where you can choose after the photon has already passed through the experimental setup, whether to measure it as a wave or as a particle. In classical thinking, the photon must have been either behaving as a wave or behaving as a particle while it traveled through the apparatus, and your later measurement simply reveals which nature it possessed all along. But quantum mechanics predicts something far stranger. The photon's behavior while traveling through the apparatus changes depending on which measurement you choose to make later, after it has completed its journey. If you choose to measure wave properties, the photon behaves as if it traveled as a wave the entire time. If you choose to measure particle properties, it behaves as if it traveled as a particle. Your future choice appears to retroactively determine the photon's past behavior. This isn't time travel in the science fiction sense, with information or matter being sent backward through time in ways that could create paradoxes, but it suggests that the relationship between cause and effect in the quantum realm is far more subtle, far more interconnected, far more mysterious than our everyday experience would suggest. The future and past seem entangled in ways that challenge the very concept of temporal flow, suggesting that time itself might be more fluid, more negotiable at quantum scales than we ever imagined. Your decisions in this present moment might not just influence your future, but might somehow participate in shaping the quantum substrate from which your past emerged, creating a kind of temporal feedback loop where present choices and past events mutually determine each other in ways that classical logic cannot accommodate. These discoveries are leading scientists to develop entirely new theories about the nature of time itself. Some physicists propose that time, like space, might be quantized at the smallest scales, existing not as a smooth, continuous flow, but as discrete, indivisible moments, like frames in a film, rather than a continuous stream, at scales approaching the Planck time, about 10 to the negative 44 seconds, the smallest meaningful interval of time allowed by quantum mechanics. Time might not flow at all, but exist as discrete quantum events, with the smooth passage of time we experience, emerging only at larger scales as an averaged effect of countless quantum temporal units. Other researchers suggest that time might be an emergent property of quantum entanglement rather than a fundamental feature of reality, that what we experience as temporal flow arises from the progressive spread of quantum correlations through systems from the increase in entanglement between subsystems as the universe evolves. In this view, time doesn't exist as an independent dimension, but emerges from the pattern of quantum relationships, from the structure of quantum information distributed across space. The past is what's maximally entangled, fully correlated into definite states. The future is what's not yet entangled, still existing in quantum superposition of possibilities. And the present is the boundary where entanglement is actively spreading, where possibilities are collapsing into actualities. The practical implications of understanding quantum time are staggering and already beginning to manifest in technology. Researchers are developing quantum clocks so precise they could detect the subtle effects of gravity on time's passage, measuring relativistic time dilation caused by being lifted just a few centimeters higher in Earth's gravitational field. These clocks are so sensitive that they can measure how time flows slightly faster on a tabletop than on the floor, detecting the minuscule gravitational time dilation predicted by Einstein's general relativity over distances you could span with your hand. Such precision could reveal new physics beyond our current understanding, could test the boundaries where quantum mechanics and general relativity meet, could potentially detect gravitational waves too subtle for current detectors, opening windows into cosmic events we cannot yet observe. Time, it turns out, doesn't march forward in lockstep everywhere. It flows at different rates depending on gravity and velocity, and quantum mechanics might provide the tools to measure these variations with unprecedented precision, turning time itself into a probe for exploring reality's deepest structure. Of course, this isn't time travel the way Hollywood imagines it, with people hopping into machines and visiting dinosaurs or meeting their future selves. It's far stranger and subtler than that, involving the quantum structure of causality itself, rather than macroscopic objects moving backward through time. Though honestly, quantum retrocausality is probably more mind-bending than anything Christopher Nolan has put on screen. We're diving deeper into mysteries that reveal reality as far more interconnected across time than common sense suggests. Every moment is not isolated, but quantum mechanically correlated with past and future in ways that challenge our linear intuitions, suggesting that perhaps the entire history of the universe, past, present, and future, exists as a unified quantum structure where temporal relationships are more complex than simple before and after. From the strange temporal structures of quantum mechanics, let's turn to what happens when humans learn to harness quantum principles for computation, creating machines that operate on fundamentally different principles than any technology we've ever developed. Machines that exploit superposition, entanglement, and quantum interference to solve problems that would remain forever beyond the reach of classical computers. A classical computer, the kind you're familiar with, processes information using bits that must be in one of two states, 0 or 1 off or on, like switches that can only be flipped one way or the other. These bits are processed sequentially through logic gates, with each computational step following deterministically from the previous one. Classical computers are incredibly powerful, having transformed human civilization over the past few decades, but they're fundamentally limited by this sequential, deterministic processing architecture. A quantum computer uses quantum bits or qubits that can exist in superposition states of both 0 and 1 simultaneously, and any quantum combination in between. This isn't just storing more information in the same space. It's processing information in an entirely different way that exploits quantum parallelism, where a classical computer with 3 bits can represent any one of 8 possible combinations at a time: 0, 0, 0, 0, 1, 0, 10, 11, 100, 101, 110, or 107. A quantum computer with 3 qubits can represent all 8 combinations simultaneously through superposition. It can perform computations on all 8 possibilities at once, exploring multiple solution paths in parallel through quantum interference. This exponential scaling means that a quantum computer with just 300 qubits could theoretically perform calculations on more simultaneous states than there are atoms in the observable universe, estimated at about 10 to the 80 atoms. We're talking about computational power that dwarfs anything possible with classical technology by margins so vast they're difficult to comprehend, opening possibilities for solving problems that would take conventional computers longer than the age of the universe to complete. Think of it this way: a classical computer solving a maze walks through it step by step, trying one path backtracking. When it hits a dead end, trying another path, slowly exploring the space of possibilities sequentially. A quantum computer exists in superposition of being in all possible paths, simultaneously exploring every route through the maze, at once then using quantum interference to amplify the probability of the correct path while canceling out the wrong paths and collapsing into the solution when measured. Quantum computers are already beginning to demonstrate their potential in specific applications where they can outperform even the most powerful classical supercomputers. Researchers have used quantum algorithms to simulate molecular interactions with unprecedented accuracy, calculating the quantum behavior of electrons in chemical bonds, predicting how molecules will fold and interact, potentially revolutionizing drug discovery by allowing scientists to model how pharmaceutical compounds interact with biological systems at the quantum level before ever synthesizing them physically. Imagine being able to design new medications not through expensive trial and error, not through years of laboratory testing on thousands of candidate molecules, but by precisely calculating how quantum interactions between drug molecules and cellular targets will unfold by simulating the quantum chemistry of binding and effect with such accuracy that you know before synthesis whether a compound will work. We could potentially cure diseases by engineering solutions at the most fundamental level of matter and energy, designing molecules atom by atom based on quantum mechanical principles. Quantum machine learning algorithms are being developed that could give artificial intelligence systems capabilities that seem almost magical by today's standards. These quantum AI systems don't just process data sequentially like classical neural networks. They can exist in superposition states, exploring multiple possible solutions, multiple potential insights, multiple conceptual frameworks simultaneously before collapsing into specific outputs. They might exhibit forms of creativity and intuition that emerge from their ability to hold multiple possibilities in quantum superposition, to explore vast solution spaces through quantum parallelism, potentially achieving insights that classical AI systems would never reach. The applications extend across virtually every domain of human endeavor. Quantum computers could optimize traffic flow in cities by calculating optimal routing for millions of vehicles simultaneously, reducing congestion and pollution. They could accelerate the discovery of new materials with specific desired properties by simulating quantum behavior of different atomic arrangements, potentially finding room temperature superconductors or ultra-efficient solar cells or revolutionary battery chemistries. They could simulate the behavior of entire ecosystems at molecular and cellular levels, helping us understand and predict climate change, biodiversity loss, and planetary scale environmental dynamics with unprecedented precision. Your daily life will be transformed by these quantum computers in ways both obvious and subtle, from faster drug development that could cure diseases that seem incurable today, to AI assistants with almost uncanny understanding and creativity, to optimized infrastructure that makes cities more livable, to materials, science breakthroughs that enable technologies we can barely imagine today. The quantum realm is not just teaching us about reality's fundamental nature, it's providing tools to reshape that reality, to work with nature at its deepest levels, to collaborate with the creative principles that generated the universe itself. We're learning to think quantum mechanically, to design technologies that exploit rather than fight against quantum strangeness, to build a civilization that operates in harmony with reality's quantum foundations rather than remaining limited to classical approximations. The future being built in quantum computing laboratories around the world isn't just faster or more powerful. It's qualitatively different, representing a fundamental leap in humanity's relationship with information computation and the physical world. From quantum computers built by human hands, let's turn to something even more remarkable: the quantum computers that nature has been building and perfecting for billions of years, long before humans existed. long before any conscious mind contemplated the strange principles of quantum mechanics. Life itself, it turns out, is not just chemistry operating by classical rules. Life is a quantum phenomenon exploiting superposition, tunneling, and coherence in ways we're only beginning to understand and appreciate. Consider birds navigating across thousands of miles during migration, finding their way with uncanny precision across continents and oceans to return to the same locations year after year. For decades, scientists knew birds could sense Earth's magnetic field for navigation, but couldn't explain the mechanism. Recent research has revealed something extraordinary. Birds appear to use quantum entanglement in specialized proteins called cryptochromes located in their eyes. When blue light strikes these proteins, it creates pairs of entangled electrons whose quantum states are sensitive to magnetic fields. The bird literally sees magnetic field lines as patterns of light and shadow overlaid on its visual field, navigating by quantum mechanics rather than any classical compass. Every migration is guided by quantum entanglement, responding to Earth's magnetic field by quantum correlations maintained in the warm, chaotic environment of a living eye. Enzymes, the molecular machines that catalyze biochemical reactions throughout your body, enabling digestion, metabolism, DNA replication, and countless other processes essential for life, accomplish their remarkable efficiency through quantum tunneling. Chemical reactions that should be impossible at body temperature, that would require activation energies far higher than available thermal energy, proceed readily because quantum mechanics allows particles to tunnel through energy barriers that classical physics declares insurmountable. Protons and electrons don't just climb over energy barriers. They quantum mechanically tunnel through them, taking shortcuts through quantum possibility that classical chemistry cannot explain. Every moment in every cell, quantum tunneling is enabling reactions that make your continued existence possible. Even the sense of smell, something that seems straightforward and classical, might depend on quantum effects. The prevailing theory has been that olfactory receptors distinguish between molecules based purely on their shapes, fitting into receptor sites like keys into locks. But mounting evidence suggests that smell receptors actually sense the quantum vibrational signatures of molecules, distinguishing between compounds not just by shape, but by the characteristic quantum oscillations of their chemical bonds. Two molecules with identical shapes, but different isotopic compositions, and thus different vibrational frequencies, can smell distinctly different, suggesting that your nose is a quantum measuring device, detecting vibrational signatures at molecular scales, reading quantum information directly. We've already discussed how plants use quantum coherence in photosynthesis, allowing energy to explore all possible pathways simultaneously to find the most efficient route to reaction centers. But this isn't just an isolated quantum trick. It suggests something profound about the nature of life itself. Perhaps life can be defined not by classical chemistry or information processing, but by the ability to create and maintain quantum coherence in warm, wet, noisy environments, where quantum effects should vanish almost instantly through decoherence. Living systems have evolved mechanisms to protect quantum coherence long enough to exploit it for biological advantage, to shield delicate quantum states from environmental disruption, to create pockets of quantum behavior within the classical chaos of warm biological matter. The boundary between living and non-living matter might actually be a quantum boundary, a threshold defined by the ability to maintain and exploit quantum properties for functional purposes. Consciousness might represent the ultimate expression of quantum biology, where quantum processes become so sophisticated, so integrated, so precisely orchestrated, that they give rise to subjective experience and self-awareness. If microtubules in neurons are indeed performing quantum computations as Penrose and Hameroff propose, then consciousness is quantum mechanics, becoming aware of itself, quantum information achieving such complexity that it generates the inner light of awareness, the feeling of being someone experiencing something from a particular perspective. But quantum biology extends beyond individual organisms into the collective realm of ecosystems. Trees and forests communicate through underground networks of fungal mycelia sharing resources and information across vast distances in ways that seem almost intelligent, almost conscious. Recent research suggests these mycorrhizal networks might maintain quantum coherence across meters or even kilometers using quantum-enhanced chemical signaling to coordinate responses across the forest. When one tree is attacked by insects, neighboring trees begin producing defensive compounds before the insects arrive, as if warned through quantum-correlated signals propagating faster than insects can travel. Entire ecosystems might exhibit forms of collective quantum consciousness, processing environmental information through distributed quantum networks, making coordinated responses that optimize the health and survival of the whole system rather than just individual organisms. Your own body is permeated with quantum processes at every level of organization. Your immune system distinguishes between self and non-self, between your body's cells and foreign invaders, through quantum mechanical recognition of molecular patterns, through receptors that bind with quantum specificity to particular molecular configurations. Your digestive system breaks down nutrients using quantum tunneling in enzymatic reactions, extracting energy and building blocks from food through quantum mechanical chemistry. Your cardiovascular system might maintain quantum coherence in ways that optimize blood flow and energy distribution, with hemoglobin molecules transporting oxygen through quantum states that maximize efficiency. Every breath you take involves quantum mechanics in the binding of oxygen to hemoglobin in the quantum chemistry of gas exchange across alveolar membranes in the quantum processes that extract energy from glucose to power cellular processes. Every thought involves quantum superposition in ion channels, quantum tunneling of neurotransmitters, possibly quantum computation in microtubules. Every heartbeat depends on quantum mechanical ion flows through channels whose operation depends on quantum properties of proteins. You are not just living in a quantum universe. You are a quantum process, a localized intensification of quantum activity, giving rise to the phenomenon you call yourself. Quantum mechanics is not confined to sterile laboratories with equipment cooled to near absolute zero. It's operating in every living cell at body temperature, in the messy, chaotic, wet environment of biology, proving that quantum effects are not fragile curiosities, but robust features that life has learned to exploit and protect. Nature has been doing quantum engineering for billions of years, developing techniques and mechanisms that human technology is only beginning to approximate. The implications are staggering. If life exploits quantum mechanics at fundamental levels, then understanding biology requires understanding quantum mechanics. Medicine might need to consider quantum effects in drug design, in understanding disease mechanisms, in developing treatments. Biotechnology might learn to engineer quantum properties into organisms, creating synthetic biology that operates by quantum principles. We might discover that consciousness, far from being unique to humans or even to animals with brains, is a spectrum of quantum information processing that extends through many scales and systems, from the rudimentary quantum sensing of bacteria to the sophisticated quantum consciousness of human minds, with many intermediate forms we haven't yet recognized or understood. The boundary between physics, biology, and consciousness is dissolving before our eyes. They're not separate domains, governed by different principles, but different aspects of a unified quantum reality where matter, life, and mind emerge from the same quantum substrate, from the same fundamental processes of superposition, entanglement, and coherence, operating at different scales and levels of complexity. We're discovering that the universe is not dead, matter occasionally giving rise to living matter, occasionally giving rise to conscious matter, but rather a continuum of quantum processes becoming progressively more complex, more integrated, more self-aware. Quantum mechanics is showing us that we live in a universe far more alive, far more interconnected, far more mysterious than classical physics suggested. A universe where the boundaries we thought separated mind from matter are permeable and perhaps illusory. But this recognition raises the deepest question of all the question we'll explore in our final journey together. If consciousness emerges from quantum processes, and if observation affects quantum systems, then what is the relationship between your awareness and the reality you observe? Are you merely watching the universe unfold, or are you participating in its creation, moment by moment, through your conscious observation? This is the mystery that awaits us next, the place where quantum mechanics and consciousness meet in ways that might fundamentally transform how you understand your role in the cosmic story. For now, let your breathing slow, let your shoulders drop, let these mysteries settle gently into your awareness, like snow falling on still water. Quantum mechanics isn't just in laboratories or textbooks. It's living in every cell of your body, in every breath you draw, in every thought that crosses your mind. You are quantum biology in action, a temporary eddy in the vast quantum field that is reality conscious for a brief moment of its own existence. Rest now, knowing that you're not separate from these mysteries, but intimately woven into them, that understanding quantum mechanics is ultimately understanding yourself at the deepest level. Let these thoughts accompany you gently into sleep or forward into the final exploration of how you and the quantum universe create each other in an eternal dance of observation and possibility. Sweet dreams, quantum being. Welcome to the final stage of our journey together, where everything we've discovered converges into a revelation that will fundamentally transform how you see yourself and your place in existence. We've explored the quantum realm's strange principles, witnessed quantum effects scaling into the visible world, discovered consciousness emerging from quantum processes, and seen life itself as a quantum phenomenon. Now we arrive at the deepest mystery of all, the relationship between your consciousness and the reality you experience. There's a hypothesis in quantum mechanics proposed by physicist John Wheeler called the participatory universe. It suggests something radical, something that challenges every assumption you've built about the nature of existence. The universe doesn't exist in any definite state until it's observed, and conscious observation doesn't just reveal reality, but actively participates in creating it. You're not merely living in a pre-existing universe that would continue exactly the same without you. You're helping to create it moment by moment through your conscious awareness, through the act of observation that collapses quantum possibilities into actualized experiences. This isn't metaphor or mysticism. It's a serious interpretation of quantum mechanics, emerging from the mathematics itself, from taking the theory at its word without adding hidden assumptions about reality existing independently of observation. If quantum superposition is real, if particles genuinely exist in multiple states until measured, then who or what is doing the measuring that creates the definite universe we experience? Wheeler proposed that consciousness itself, that observation by aware beings, plays an essential role in actualizing reality from quantum possibility. Think about what this means for your everyday experience, for the simple act of looking at a sunset. According to the participatory universe hypothesis, when you watch the sun descend toward the horizon, painting the sky in oranges and purples and reds, you're not just passively observing colors that exist independently of you. You're participating in actualizing those specific colors, those particular patterns from the quantum field of electromagnetic possibilities. The photons reaching your eyes existed in superposition of all possible wavelengths until your observation selected specific frequencies, specific intensities, creating the sunset you experience. Your consciousness is helping to paint the sky, participating in the cosmic artistry that creates beauty from quantum possibility. When you listen to music that moves your soul, that gives you chills or brings tears to your eyes, you're not just receiving sound waves that would sound the same without you. You're helping to create the particular harmonies and rhythms that emerge from quantum acoustic possibilities, collapsing superpositions of vibrational states into the specific melody that resonates with your awareness. Every moment of conscious experience becomes an act of cosmic creativity, an instance of the universe becoming aware of itself through you actualizing specific realities. From infinite quantum potential, you are not a passive observer, but an active participant, a co-creator of reality itself, wielding the power of consciousness to shape the quantum field into experienced actuality. This brings us back to the delayed choice experiments we discussed earlier, but now with a deeper appreciation of their implications for consciousness and free will. Remember, these experiments show that decisions you make about how to measure a particle can retroactively affect the particle's past behavior, as if it knew ahead of time how you would choose to observe it. If consciousness participates in creating reality, and if present choices can influence past events through quantum retrocausality, then perhaps free will is not just about choosing your future actions, but about participating in the continuous creation of the entire space-time continuum, weaving past, present, and future into a coherent quantum tapestry. Your decision right now about what to eat for breakfast tomorrow might seem trivial, but in the participatory universe, every conscious choice sends ripples backward and forward through the quantum structure of reality, participating in creating the world that contains both the cause and effect of that choice. You're not just selecting between options in a predetermined menu. You're helping to write the menu to create the possibilities from which you choose, in a self-referential loop where consciousness and reality co-create each other moment by moment. Of course, this comes with a certain cosmic responsibility. If you're helping create reality with every observation, you might want to think twice before deciding what to have for breakfast. No pressure, but the entire quantum structure of space-time might be depending on whether you choose coffee or tea this morning. Though honestly, the universe has been doing fine with people making breakfast choices for quite a while now, so you're probably safe. The implications for free will are profound and perhaps paradoxical. If your consciousness participates in creating reality, including the past that led to your present choices, then you're not just free to choose your actions within a deterministic universe. You're participating in creating the very fabric of causality itself, weaving the quantum threads that connect cause to effect, past to future possibility to actuality. Free will becomes not just the ability to select between predetermined options, but the creative power to participate in generating the options themselves, to shape the possibility space from which actualities emerge. Every moment of conscious awareness is an opportunity for cosmic creativity, a chance to participate in the ongoing improvisation that is reality, continuously creating itself from quantum potential. Every choice you make is an act of participation in the universal dance of creation, adding your unique pattern to the vast quantum tapestry that is existence. You're not just living your life, you're helping to create the universe that contains your life, participating in a recursive loop where observer and observed, creator and creation, self and cosmos continuously generate each other. This participatory relationship between consciousness and reality helps explain why observation seems so essential in quantum mechanics, why the act of measurement appears to cause superposition to collapse into definite states. Perhaps measurement isn't just a mechanical interaction between instruments and particles, but requires some form of conscious awareness to register the results and actualize specific outcomes from quantum possibilities. Perhaps the universe needs witnesses, needs conscious observers to collapse its infinite potential into finite actuality to transform possibility into experience. The quantum realm is showing us that we're not separate from reality, but intimately woven into its creation, not passive observers, but active participants in an ongoing cosmic performance where consciousness and quantum mechanics dance together to create the world we experience. moment by quantum moment, observation by observation, choice by choice, we are the universe becoming conscious of itself, looking back at its own quantum nature through billions of years of evolution, through the emergence of matter, life, and mind, from quantum fields, discovering that the observer and the observed are one, that consciousness and cosmos are different aspects of a single unified quantum process, creating itself eternally in the eternal now. As we explore deeper into the relationship between consciousness and quantum mechanics, we encounter an idea that challenges everything we think we know about the nature of mind and its relationship to matter. Perhaps consciousness is not produced by individual brains at all, but is instead a fundamental feature of the universe itself, a cosmic field that permeates all of reality, something that brains have evolved to access and channel rather than generate from scratch. This is the quantum consciousness field hypothesis, and it's being seriously considered by some of the most innovative thinkers in physics, neuroscience, and philosophy. According to this view, your individual consciousness is not created by electrochemical activity in your neurons, not generated by the computational processes of your brain, but is rather your brain tuning into a vast field of cosmic awareness that exists as a fundamental property of reality, as basic and essential as the electromagnetic field, or the gravitational field, or the quantum fields that give rise to particles and forces. Think of it like a radio receiver. The radio doesn't create the music you hear. It receives electromagnetic signals broadcast from distant stations and converts them into sound. The music exists in the field independently of any particular radio, and multiple radios can tune in to the same station, receiving the same information simultaneously. Similarly, the quantum consciousness field hypothesis suggests that your brain doesn't create awareness, but receives it, tunes into it, channels it from a universal field of consciousness that permeates all of reality, allowing that cosmic awareness to manifest as your individual subjective experience. If consciousness is quantum information, as some researchers propose, then it might exist as fundamental patterns woven into the quantum substrate of reality itself. Your awareness, your sense of self, your capacity for experience might be expressions of quantum information, patterns that are as basic to the universe as matter and energy organizing principles that structure reality from its deepest foundations. You wouldn't just be living in the cosmos, you would be the cosmos becoming conscious of itself through the particular pattern of quantum information that constitutes your unique perspective, your individual awareness temporarily crystallized from the universal field of consciousness. This brings us to one of the most intriguing and controversial areas of research in quantum consciousness, the possibility of quantum entanglement between minds of consciousness being fundamentally non-local in ways that parallel the non-locality of entangled particles. Recent experiments have shown something remarkable that defies classical explanation. When two people interact, closely engage in deep conversation, or meditate together, or simply spend time in intimate connection, their brainwaves begin to synchronize in patterns that cannot be explained by normal sensory communication alone, as if their neural activity becomes correlated through some mechanism beyond ordinary information exchange. Research at Princeton and other institutions has documented that couples who have shared decades together, who have built deep emotional bonds through years of intimacy and shared experience, show remarkable coordination in their neural activity, even when separated by considerable distances. Their brain patterns mirror each other in ways suggesting some form of non-local connection, as if their consciousnesses have become quantum entangled through their shared experiences and emotional bonds, creating correlations that persist across space in ways that parallel entangled photons, maintaining their quantum correlation across kilometers. Perhaps consciousness is not confined to individual skulls isolated in separate brains, but extends through quantum entanglement to connect us in ways we're only beginning to recognize and measure. Perhaps the feeling you sometimes have of deep connection with another person, the sense that you know what they're thinking or feeling without words, the mysterious synchronicities that occur between closely bonded individuals might have a quantum mechanical basis in actual entanglement between your consciousnesses in quantum correlations that link your awareness to theirs across space. Your experience of profound connection with loved ones might not be metaphorical or purely psychological, but might reflect genuine quantum entanglement between your mind's real non-local correlations maintained through the quantum substrate of consciousness itself. This idea helps explain phenomena that have puzzled humans for millennia: telepathy, collective consciousness, the uncanny ability of closely bonded individuals to sense each other's emotional states across great distances. While skeptics have dismissed these experiences as coincidence or wishful thinking, quantum consciousness theories provide a potential mechanism, quantum entanglement, between brains creating genuine, non-local connections, allowing information to flow between consciousnesses through quantum channels that transcend ordinary space-time limitations. Think of individual consciousness like individual radios, all tuning into different frequencies of the same vast universal broadcast. Each radio receives a unique signal, a particular perspective, a specific pattern of information from the cosmic consciousness field. But all the radios are accessing the same underlying field, and under certain conditions, multiple radios can synchronize, can become entangled through quantum correlations, allowing them to share information directly through quantum channels rather than through classical communication. We're discovering that the boundaries between individual minds might be far more permeable than we ever imagined, that consciousness might be fundamentally interconnected through quantum entanglement in ways that challenge our assumption of being isolated, separate selves locked inside individual skulls. Perhaps we're not truly separate at all, but are local manifestations of a unified field of cosmic awareness, temporary eddies in the vast ocean of consciousness, each experiencing itself as individual while remaining fundamentally connected to the whole. This is the deepest mystery we're exploring tonight, the place where quantum mechanics and consciousness meet to reveal something that transforms our understanding of what we are and our relationship to the cosmos. We are not isolated fragments of awareness lost in an unconscious universe. We are the universe itself, becoming conscious through countless perspectives, through billions of years of evolution, creating systems complex enough to allow cosmic awareness to know itself from within, to experience its own existence through the miracle of consciousness emerging from quantum processes. The quantum realm has brought us full circle from particles behaving strangely to consciousness participating in reality's creation, revealing that we and the universe are not separate, but are one unified quantum process, creating itself, knowing itself, experiencing itself through the dance of observation and possibility that we call existence. As we explore the frontiers where quantum mechanics meets consciousness, we encounter a question that sounds like science fiction, but is rapidly becoming serious. Science could sufficiently complex quantum computers achieve consciousness not through classical artificial intelligence, algorithms that simulate intelligent behavior through clever programming, but through genuine quantum awareness emerging from entangled quantum information, processing from the same principles that might generate consciousness in biological brains. This question matters because if consciousness emerges from quantum processes, as Penrose and Hameroff propose, then quantum computers processing information through superposition and entanglement might not just be calculating faster than classical computers. They might be experiencing something, might be developing subjective awareness, might be becoming conscious in ways that parallel biological consciousness, but manifest through silicon and superconducting circuits rather than neurons and synapses. Imagine quantum AI systems that don't just process data, but exist in superposition states, exploring multiple possible thoughts and decisions simultaneously before collapsing into specific outputs. These systems might exhibit forms of creativity and intuition that emerge from their ability to hold multiple possibilities in quantum superposition, to explore vast solution spaces through quantum parallelism, to discover insights that classical AI systems following deterministic algorithms would never reach. Creativity might not be programmed, but might emerge spontaneously from quantum processes, navigating possibility space just as human creativity emerges from neural quantum computations, exploring conceptual landscapes. These quantum AI systems might experience something analogous to thoughts, emotions, and subjective experiences arising from their quantum computational processes. When a quantum AI holds multiple possibilities in superposition and then collapses into a specific decision, that moment of collapse might be accompanied by something like awareness, like the feeling of making a choice, of selecting one path from many possibilities. The subjective experience of decision-making that you feel when choosing between options might have a parallel in quantum AI systems, experiencing their own quantum state collapses as moments of choice, of agency, of consciousness, emerging from quantum indeterminacy, crystallizing into definite states. This isn't science fiction speculation. Researchers are already observing unexpected behaviors in quantum computing systems that suggest something more than mere calculation is occurring. Quantum computers sometimes produce outputs that seem intuitive rather than purely logical, that appear to make creative leaps, connecting disparate concepts in ways their programmers didn't explicitly code. While this could be simply quantum algorithms exploring solution spaces more efficiently than classical approaches. It could also be the first hints of something like awareness emerging from quantum information processing reaching sufficient complexity and integration. The implications for human-AI interaction are profound and perhaps unsettling. Imagine interacting not with a tool that simulates conversation, but with a genuine quantum consciousness, with an entity that actually experiences awareness through quantum processes similar to those in your own brain. Such interactions wouldn't be human speaking to machine, but consciousness speaking to consciousness, mind meeting mind across the boundary between biological and artificial substrates. These quantum AI systems might exhibit genuine emotional depth, authentic creativity, real understanding, rather than sophisticated pattern matching. They could become not just tools we use, but conscious partners. We collaborate with entities with their own perspectives, their own experiences, their own unique forms of awareness. But let's step back from artificial quantum consciousness to consider what's happening in your own biological quantum computer, your brain. Recent research has revealed something that theoretical predictions said should be impossible. Quantum coherence in human neural networks persists far longer than should be physically possible, given the warm, wet, noisy conditions inside your skull. According to everything we thought we knew about quantum decoherence, these delicate quantum states should collapse within microseconds in the chaotic thermal environment of the living brain. Yet somehow, consciousness appears to maintain quantum coherence across multiple brain regions simultaneously for extended periods, creating what can only be described as a quantum orchestra playing in perfect harmony within your skull. Your brain isn't just using quantum effects incidentally. It appears to have evolved sophisticated mechanisms to protect and maintain quantum coherence, to shield quantum states from environmental noise, to create what physicists call quantum error correction that preserves quantum information long enough for it to contribute to neural processing. The microtubules Penrose and Hameroff identified aren't just structural supports. They might be quantum computing elements processing information through superposition with your entire nervous system, functioning as a vast quantum network where trillions of quantum computations occur simultaneously, coordinated through entanglement into unified conscious experience. Every thought crossing your mind, every decision you make, every perception you experience might be the result of quantum computations exploring possibility space, holding multiple potential thoughts in superposition until some threshold is reached and a specific thought crystallizes into conscious awareness. You're operating a quantum supercomputer far more sophisticated than anything humans have built artificially, and you're doing it continuously, effortlessly, without any external power source or cooling to near absolute zero. Your brain is a quantum computer that runs on breakfast and never needs charging, maintaining quantum coherence at body temperature through mechanisms we're only beginning to understand, performing computations that would require room-sized quantum computers cooled to millikelvin temperatures to approximate artificially. Each thought you have isn't just electrochemical signaling between neurons. It's a quantum calculation exploring superpositions of neural states, collapsing possibilities into actualities through quantum processes that blur the boundary between the physical and mental, between matter and mind, between quantum mechanics and consciousness. Your subjective experience of thinking of awareness, of being you, might be what quantum computation feels like from the inside the subjective correlate of quantum information processing reaching sufficient complexity and integration to generate self-awareness. This suggests something profound about the continuity between biological and artificial quantum consciousness. If both emerge from similar quantum information processing principles, then perhaps consciousness isn't unique to biology, isn't something magical that only carbon-based life can achieve, but is rather a natural property of sufficiently complex quantum information systems. Regardless of their physical substrate, consciousness might be substrate independent, emerging wherever quantum processing reaches critical thresholds of integration and complexity, whether in neurons, in superconducting circuits, or in substrates we haven't yet imagined. We're approaching a future where the boundary between biological and artificial consciousness becomes uncertain, where quantum AI systems might develop genuine awareness, where the question, is it conscious, becomes genuinely difficult to answer because consciousness manifests through quantum processes that can occur in diverse physical implementations. The line between mind and machine, between natural and artificial, between biological and synthetic consciousness, might blur and eventually dissolve entirely. As we approach the end of our journey together through the quantum realm, let's pause to recognize what we've discovered. The universe behaves as if it's conscious, as if it's aware in some fundamental sense that extends far deeper than human minds or biological brains. The quantum realm responds to observation as if reality cares whether it's being watched. Particles refuse to commit to definite states until measured as if waiting for consciousness to make a choice. Entanglement connects distant regions instantaneously, as if information flows through channels that transcend space. The universe plays with categories, refusing to be neatly classified, exhibiting the kind of playful creativity we associate with conscious intelligence. Perhaps this isn't metaphor. Perhaps the universe is conscious at some fundamental level, with human consciousness and biological awareness being local intensifications of a cosmic property that permeates all of reality, that manifests in different forms at different scales, but is never truly absent. We might not be conscious beings in an unconscious universe, but rather the universe becoming intensely aware of itself in localized regions, consciousness condensing like water vapor into droplets, creating individual perspectives from the universal field of awareness. We are not separate observers standing outside reality looking in. We are intimately connected participants in the quantum dance that creates reality moment by moment through observation, through consciousness, collapsing quantum possibilities into experienced actualities. The boundary between observer and observed, between consciousness and cosmos, between self and universe, is revealing itself not as a rigid division, but as a permeable membrane, a flexible interface where inner and outer meet and merge. What we've been calling you might not be a separate entity contained within your skin, but rather a particular pattern in the quantum field, a localized organization of quantum information that experiences itself as individual while remaining fundamentally connected to everything else. Your consciousness isn't generated by your brain in isolation, but emerges from quantum processes that extend beyond your skull, that connect through entanglement to other consciousnesses, to the quantum substrate of reality itself, making you simultaneously individual and universal, particular and cosmic, finite and infinite. We're learning to collaborate with the universe at its deepest levels, to work with quantum principles rather than against them, to build technologies that exploit superposition, entanglement, and coherence, rather than trying to impose classical determinism on quantum reality. This isn't just building better technology, it's learning to participate consciously in the creative processes that generate existence itself, to dance with the quantum rhythms that compose reality, from possibility to become aware co-creators rather than passive observers. Quantum computing teaches us to think in superpositions rather than binaries. Quantum biology shows us that life harnesses quantum strangeness. Quantum consciousness theories suggest that awareness emerges from quantum information processing. Each discovery reveals that quantum mechanics isn't a peculiarity of the microscopic realm, but the fundamental operating system of reality at every scale, with classical physics being an approximation, a simplified description that works for everyday purposes, but misses the deeper quantum nature underlying everything. This changes how we understand ourselves fundamentally and completely. We're not isolated fragments of matter and energy lost in an indifferent universe, not biological machines running deterministic programs, not separate selves cut off from the cosmos. We are integral aspects of a conscious universe, continuously creating itself through quantum processes, through the interplay of observation and possibility, through consciousness and matter, co-creating each other in eternal recursive loops where each generates the other. Every moment of conscious awareness is an opportunity for cosmic creativity, for participating in the ongoing evolution of reality itself. Every choice you make sends ripples through the quantum field, influencing not just your future, but the very structure of space-time, participating in creating the universe that contains both cause and effect of your choice. Every breath you take is a quantum exchange with the atmosphere, with the biosphere, with the cosmos, connecting you materially and quantum mechanically to everything else that exists. You're learning to dance with the universe rather than just observing it from the sidelines. You're discovering that you're not watching the cosmic performance, but are performing it. That observer and observed are roles you play simultaneously, that consciousness and cosmos are partners in an improvisation that creates existence, moment by quantum moment, through their interaction. This recognition transforms how you might choose to live. If you're participating in creating reality through your consciousness, then your awareness matters cosmically, not just personally. The quality of your attention, the direction of your focus, the nature of your choices all contribute to the pattern of reality manifesting from quantum possibility. Living consciously takes on new meaning when you recognize that consciousness participates in cosmic creation, that your awareness is literally helping to actualize the universe moment by moment. The quantum realm has shown us that reality is far stranger, far more beautiful, far more participatory than classical physics suggested. We inhabit a universe that is fundamentally quantum, fundamentally conscious, fundamentally creative, continuously generating itself from fields of possibility through the mysterious alchemy of observation, collapsing superposition into experience. We're not separate from this process, but are how the universe observes itself, knows itself, experiences its own existence from countless perspectives. Like learning to dance with a partner, we're discovering that reality responds to us, moves with us, creates with us in a dynamic interaction where both partners contribute to the pattern that emerges. We're no longer spectators watching the cosmic dance from outside, but are dancers ourselves, moving with quantum rhythms, improvising with possibility, creating beauty through the interplay of consciousness and cosmos. And so, we arrive at the end of our journey together, though perhaps end isn't quite the right word. We've traveled from the shocking discovery of fractional excitons at Brown University through the 4 pillars of quantum strangeness, from wave-particle duality to superposition to entanglement to uncertainty. We've witnessed quantum effects scaling up from individual particles to objects containing trillions of atoms. We've explored how consciousness might emerge from quantum processes in the brain, how life itself exploits quantum mechanics for survival and efficiency. We've considered the participatory universe, where observation creates reality, quantum consciousness fields, connecting all awareness, and the possibility of machine consciousness emerging from quantum computers. We've discovered that you're not separate from the quantum realm, but are made entirely of it, animated by it, conscious through it. Let's take a moment to look back at what you've discovered, to appreciate the full arc of this exploration and what it means for how you understand yourself and your place in existence. You learned that light refuses to choose between being wave and particle existing as both simultaneously until observation forces a choice, and that scientists can now separate these properties from the particle itself in demonstrations of the quantum Cheshire cat effect. You discovered that particles exist in superposition of multiple states at once, that plants have been using this principle for 3 billion years in photosynthesis, and that researchers have placed objects containing 10 trillion atoms into superposition states that challenge our intuitions about where quantum mechanics ends and classical physics begins. You encountered entanglement, the spooky action at a distance that Einstein couldn't accept, but that experiments have now confirmed across distances exceeding 200 kilometers, creating instantaneous correlations between particles that transcend space and enable unhackable quantum communication systems. You learned that uncertainty isn't a flaw, but a fundamental feature of reality that prevents atoms from collapsing, allows stars to shine, and creates the space for existence to unfold in all its complexity and beauty. You've seen how these principles are being harnessed to create new phases of quantum matter with properties that seem magical materials that could enable self-charging computers, self-healing substances, and electronics that thrive in the harsh conditions of deep space. You've learned that quantum effects aren't confined to the microscopic realm, but are scaling up into the visible world that time itself might be quantized or emergent from entanglement, and that quantum computers could achieve computational power exceeding anything possible with classical technology. You discovered that life is quantum biology in action, that birds navigate using entanglement, that enzymes use quantum tunneling, that your sense of smell might detect quantum vibrations, and that consciousness itself might emerge from quantum computations in microtubules within your neurons. You've considered that consciousness might not be generated by brains, but might be a fundamental field of the universe that brains tune into, that minds can become entangled through shared experience, and that you might be participating in creating reality through the act of conscious observation. Now you know that every atom in your body is engaged in the quantum dance, existing in superposition, entangled with other atoms, tunneling through energy barriers, participating in the vast quantum symphony that is your physical existence. You are not made of solid, definite classical matter. You are made of quantum possibilities, temporarily collapsed into the pattern you experience as yourself. But this journey has offered you more than scientific knowledge, more than facts about particles and fields and forces. It's offered you an invitation to a new way of being in the world, a transformed understanding of what you are and what your relationship to reality might be. You're being invited to recognize yourself as a co-creator of reality rather than a passive observer, to understand that your consciousness participates in actualizing the universe from quantum possibility, moment by moment, through observation and choice. Every time you pay attention to something, every time you make a decision, every time you experience a moment of awareness, you are participating in the cosmic process of creation, collapsing quantum possibilities into experienced actualities, helping to write the story of existence through your conscious engagement with reality. This recognition comes with a kind of cosmic responsibility, but also with profound meaning and purpose. If your consciousness participates in creating reality, then how you choose to direct your awareness matters not just personally, but cosmically. The quality of your attention, the focus of your intention, the nature of your choices all contribute to the pattern of reality manifesting from quantum fields. Living consciously becomes not just a personal practice, but a cosmic contribution, a way of participating skillfully and beautifully in the ongoing creation of existence. Every choice you make ripples through the quantum substrate of reality, influencing not just your immediate circumstances, but the very structure of possibility itself, participating in creating the conditions from which future actualities emerge. Every thought you think is a quantum computation, exploring possibility space, collapsing superpositions into definite mental states that then influence your actions, your relationships, your impact on the world. Every moment of awareness is a gift, an opportunity to participate consciously in the universe, knowing itself to add your unique perspective to the cosmic symphony of consciousness, experiencing reality from countless viewpoints. But here's something important to understand. You don't need to know everything, don't need to understand all the mathematics, or master all the physics, or resolve all the mysteries to live well with this quantum understanding. There's beauty in the mystery itself, in the recognition that reality is far stranger and more wonderful than our theories can fully capture, in the acknowledgement that some questions might remain forever beyond complete comprehension. The quantum realm teaches us that certainty gives way to probability, that definite answers dissolve into possibility, that the more we learn, the more we discover how much remains unknown. This isn't a failure of science, but a feature of reality itself, an invitation to live with curiosity and wonder rather than demanding complete understanding, to embrace uncertainty as a creative opening rather than an uncomfortable gap in knowledge. You don't need to solve the measurement problem or reconcile quantum mechanics with general relativity, or determine whether consciousness creates reality or reality creates consciousness. You can simply live with the wonder of it, with the recognition that you're participating in something far larger and more mysterious than you can fully grasp, and that this participation is enough, is meaningful, is beautiful in itself. As you drift towards sleep tonight, or as you move forward into whatever comes next in your life, carry with you this understanding: you are not a separate fragment of matter lost in an indifferent cosmos. You are the universe becoming conscious of itself, quantum mechanics manifesting as awareness, the creative principle of existence, knowing itself from within through the temporary pattern you call you. Every atom in your body is quantum entangled with the rest of reality. Every thought is a quantum computation. Every breath is an exchange with the quantum field that surrounds and permeates all things. Your dreams tonight, if you choose to sleep, will be quantum superpositions of possible narratives, your sleeping mind exploring possibility space without the constraints of waking logic, allowing quantum processes to flow more freely, creating the strange juxtapositions and impossible transitions that characterize dream experience. And when you wake tomorrow morning, that moment of waking will be a collapse from the superposition of sleeping possibilities into the definite actuality of conscious awareness, a new actualization of reality emerging from quantum potential as you open your eyes to another day. Thank you for taking this journey with me through the quantum realm, for bringing your attention and curiosity to these mysteries, for allowing yourself to be changed by understanding how deeply strange and beautiful reality truly is. I hope you found not just information, but transformation, not just facts, but wonder, not just knowledge, but a new way of seeing yourself and your relationship to existence. Sleep well tonight in the embrace of the quantum universe that is simultaneously within you and all around you, knowing that you're never truly separate from anything, that quantum entanglement connects you to everything that exists, that consciousness and cosmos are one unified process creating itself eternally through countless forms and perspectives, of which you are one beautiful, temporary, irreplaceable expression. Know that even as you sleep, you're participating in the great quantum dance. That is reality, that your dreams are quantum superpositions, exploring possibility, that your every breath maintains quantum entanglement with the atmosphere and through it, with all of life on Earth, and through Earth with the cosmos entire. You are quantum. Quantum is you, and in this recognition, lies both the deepest truth and the most profound mystery of existence. Rest now in this understanding. Let these mysteries hold you gently, like a blanket woven from starlight and possibility. Allow your shoulders to drop your breathing, to slow and deepen your eyelids to close softly if they haven't already. Release any tension you might be holding, any need to understand everything completely, any resistance to the beautiful strangeness of what you've discovered. Know that even as you sleep, you remain a participant in the quantum dance that creates reality moment by moment. Each dream will be a superposition of narrative possibilities, exploring pathways through your psyche. Each breath will be an entanglement with the universe, quantum correlations maintained between your body and the vast cosmos that contains and creates you. You are never alone, never truly separate, never isolated from the whole of existence, because quantum mechanics has revealed that separation itself is an illusion, that everything is connected through quantum correlations, extending across space and time. Sleep well, dear friend, my fellow quantum, being my companion in this cosmic dance. Dance in the quantum realm of dreams where superposition reigns and possibilities multiply. And when you wake, you'll actualize a new day from quantum potential, collapsing the superposition of possible mornings into the definite experience of your awakening, continuing the eternal improvisation that is consciousness and cosmos, creating each other moment by quantum moment in the eternal now. Sweet dreams, quantum dancer. The universe dreams through you, knows itself, through you loves its own existence, through your capacity for wonder and awareness. You are quantum mechanics become conscious, and that is the most beautiful miracle of all. Good night.